You consume it daily. You go through more than you probably realize. You are literally made of it. But how much do you really know about water? Join me, Lake Storywater, and my droid, H2O, as we travel in search of the science behind water and water-related concepts. This is Story of Water. A little over 70% of Earth's surface is covered by water, which seems like a lot, right? But in terms of how much water exists on our planet compared to the total mass of our planet, water makes up only about 0.02% of Earth's mass. We don't even have the most water in our solar system. There are other places in the solar system that contain water, much more water than we have here on Earth. Some worlds have ice water, some even have liquid water. Using our exploration vehicle, the Aquarius, let's visit some of the other places in space that have water. Taking off from Earth, we'll head away from the Sun. Our first destination, though, isn't very far, in astronomical units at least. Our closest neighbor, the Moon, is our first stop. The Moon has more water than you are probably aware of. Water made its way to the Moon billions of years ago when comets and asteroids containing water slammed into the Moon. In the resulting impact craters at the poles, water, in ice form, still remains. These craters have areas that don't receive any sunlight, and the temperature never gets above negative 418 degrees Fahrenheit here. Scientists confirmed the presence of water ice here in 2008. The poles aren't even the only place you can find water on the Moon. Just a year later, in 2009, a NASA mission detected trace amounts of water molecules in the Moon's thin atmosphere. Water also exists in the lunar soil. Solar wind contains protons that interact with oxygen molecules in the soil to form small particles of water. However, it is in such small amounts that the lunar soil is still 100 times drier than that of Earth's deserts.
How much water is on the Moon?
It is estimated that the poles contain 600 billion kilograms of ice. To put that into perspective, that amount would fill 240,000 Olympic-sized pools. That amount of water could come in handy in the future, perhaps used to make oxygen or drinking water for a moon base, or for fuel for a rocket. Speaking of rocket fuel, I think it is time we use some to head to our next destination. Mars, the red planet. Like the Moon, Mars also contains water ice at its poles and a trace amount in its thin atmosphere. Evidence in the form of riverbeds and gullies indicate that liquid water once flowed on Mars. Flatter plains also suggest that there might have even been an ocean.
What happened? Where is the water now?
Billions of years ago, Mars was much warmer. In fact, it was warm enough to allow for this liquid water. Mars's thin atmosphere didn't do a good job of keeping evaporated water from leaving the atmosphere, so some of it was lost to space. As Mars cooled, water at the poles froze, and much of Mars's water remains here. In fact, surface ice is visible at the northern polar ice cap. The ice here is estimated to be 3 kilometers thick and contain 821,000 cubic kilometers of ice, roughly about a third the size of Greenland's ice sheet. The south polar ice cap is layered with ice and dust and is about 1.5 kilometers thick. Under this ice cap, there is also evidence that a 20-kilometer lake of at least 3 feet of liquid salt water exists. Another similarity to the Moon is that there is also a trace amount of water vapor in Mars's thin atmosphere. In 2008, water was discovered in the Martian soil by Phoenix, a NASA rover. It dug into rocks and detected water vapor. It is estimated that there is enough water ice contained in the soil just under the surface to fill Lake Michigan twice. The most current research actually suggests that most of Mars's water is locked away within hydrated rocks and minerals. Even with all the water we know about on Mars, there could still be much more available beneath the surface. Traveling through the asteroid belt, which is located between Mars and Jupiter, we come to the dwarf planet Ceres. In 2014, the Herschel Space Observatory detected water vapor plumes escaping into space from Ceres' surface. A year later, in 2015, NASA's Dawn orbiter arrived at Ceres to begin studying this world. Based on high-resolution images Dawn collected, scientists found what looked like a briny liquid had seeped out of Ceres' surface. Further analysis led scientists to conclude that the source was a liquid saltwater reservoir that exists 25 miles below the surface.
How big is the reservoir?
Although there is no sure way to know how big this reservoir is, some estimates place it at hundreds of miles wide. Also on the surface of Ceres are bright spots of hydrohalite, which is like salt with ice contained in its crystals. Combining this trapped ice with the underground reservoir, it is estimated that up to 30% of Ceres' mass and 50% of its volume is actually water. Leaving the asteroid belt, we come to the biggest planet, Jupiter. Jupiter isn't our destination in our search for water, though. 3 of its moons are. The first moon we encounter is Europa. Scientists believe with much certainty that beneath Europa's icy crust lays a liquid saltwater ocean.
How do they know this?
The first evidence came from NASA's Galileo spacecraft, which measured the magnetic field of Jupiter from 1995 to 2003. Disturbances in the magnetic field near Europa led scientists to conclude that there must be a large, electrically conductive fluid contained within Europa, similar to a saltwater ocean. Even more evidence was discovered in 2013 when the Hubble Space Telescope detected hydrogen and oxygen in plumes erupting over 100 miles high from Europa's surface. This evidence was confirmed in 2019 when scientists at the Keck Observatory detected enough water vapor being released from these plumes to fill an Olympic-sized pool in minutes.
Where is the water?
Well, beneath a 10 to 15 mile thick layer of icy crust is an ocean anywhere from 40 to 100 miles deep. That would be twice as much water as all of Earth's oceans combined. NASA is planning a Europa Clipper probe mission later this decade to study this water world. The next moon to explore is Jupiter's and the solar system's largest. Ganymede, much like Europa, is believed to contain a liquid saltwater ocean below its icy crust. The Galileo spacecraft gave us the first evidence of this, in the same way it detected changes in Jupiter's magnetic field when Galileo passed near. Scientists believe the ocean to be 60 miles deep, which would be 10 times deeper than anywhere in Earth's oceans. It is buried under a 95-mile thick icy crust. Evidence for an ice water crust came in 2019 when NASA's Juno orbiter collected data that confirmed water ice presence across the northern hemisphere of Ganymede. Based on all this information, Ganymede is the wettest world in our solar system.
How so?
Well, with 46% of this world composed of liquid water, this equates to over 30 times more water than on Earth. Later this year, NASA's Juno spacecraft will fly by and observe Ganymede and Europa. Jupiter's next moon, like the previous two, contains a liquid saltwater ocean beneath its surface. Callisto, just like the other two, caused changes in Jupiter's magnetic field as detected by the Galileo spacecraft. However, Callisto's icy crust is much thicker than even Ganymede's, at 120 to 155 miles thick. Scientists aren't sure how deep the ocean is here, but it is likely at least 6 miles deep. Even at that estimate, Callisto still contains more water than Earth's oceans.
How much more?
Well, perhaps 3 times as much water as on Earth. The European Space Agency is launching a spacecraft next year that will travel to Callisto, Ganymede, and Europa. Next, we move on to the ringed planet Saturn to take a look at a few of its moons. The first moon we encounter is Saturn's largest, Titan. Titan is another moon with an icy crust layer. In 2011, NASA's Cassini spacecraft found evidence of a subcrust water layer by detecting how the moon bulges when pulled near Saturn. Much like how the moon causes tides on Earth, Saturn pulls the water in the underground ocean. Titan is similar to Earth in other ways. First, it has a thick atmosphere made mainly of nitrogen. The atmosphere exerts a much greater pressure than on Earth, so much so that rain falls 5 times slower than on Earth.
It rains here?
Yes, and Titan has clouds, rivers, lakes, and seas on its surface. Although it has liquid on the surface, the liquid isn't actually water. It is made of liquid hydrocarbons, such as methane and ethane. But there is water. About 30 miles below the icy crust is a saltwater ocean that is as salty as the Dead Sea. Estimates vary, as scientists aren't sure if there's one ocean layer up to 150 miles deep, or if there are layers of ice sandwiched within it. Still, up to a quarter of Titan's volume may be water, which means that there would be 12 times more water on Titan than on Earth. If this is the case, then only Ganymede would hold more water than Titan. Saturn's next moon, Enceladus, shares some characteristics with Titan. It is covered by an icy crust layer that is 19 to 25 miles thick in some places. It is also so bright white that it is actually the most reflective object in the solar system. While Cassini was in the neighborhood, it also studied Enceladus. What it found was plumes of water vapor and ice shooting out hundreds of miles into space from fissures at its south pole. Cassini also detected the presence of silica in these plumes, which are formed when liquid water and rock interact at temperatures above 200 degrees Fahrenheit. This evidence suggests that beneath a thin crust at the South Pole, which may be less than a mile thick there, is an ocean of warm liquid water that is heated by hydrothermal vents. This would be very similar to the conditions deep in Earth's oceans.
How deep is this ocean?
Scientists estimate that the ocean below Enceladus' south pole may be 6 miles deep, which is comparable to Earth's oceans, and may also extend throughout the entire moon. Before we leave Saturn, let's take a quick look at one more moon that may contain water. Cassini also studied Mimas, and scientists noticed the moon had a wobble as it orbited Saturn. This wobble is either due to a core that's shaped like a football, or it contains a liquid water ocean 15 to 20 miles below the icy surface. Scientists don't have enough information to say for certain, so Mimas will, for now, remain an intriguing candidate for being a water world. Leaving Saturn, we skip past Uranus and even further away from the Sun to Neptune. Neptune's largest moon, Triton, may also contain water. Since Triton is so far from Earth, only one spacecraft, Voyager 2, has gotten close enough to study it.
What did it find?
It spotted plumes rising from its surface. Based on what scientists discovered about Enceladus's plumes, it is reasonable to assume that Triton may also be hiding an ocean under its frozen nitrogen crust. Since there is so little information to go on, there is no clear consensus on how much liquid water, if any, exists below the surface. There may just be water ice below the surface, or some of that water ice could have melted and remained as liquid water between layers. Whatever the case, the amount of liquid water on Triton is well less than the amount of liquid water on Earth. The final stop on our search for water is well beyond Neptune in the Kuiper Belt. Not much was known about the dwarf planet Pluto until 2015, when NASA's New Horizons spacecraft visited it. New Horizons revealed a world covered by nitrogen and methane ice, sitting atop a layer of 30% water ice and 70% rock. In one location, the water ice and rock layer was estimated to be 6 miles thick. Below this layer, scientists speculate that there once was a vast liquid water ocean, and that there still may be some of it remaining. Numerous large cracks on Pluto's surface suggest that its liquid water ocean froze over time and thus expanded, causing the cracks in the crust to form. Much like placing a water bottle in a freezer will cause the bottle to burst.
How much water is there?
Depending on how deep and how much water remains, Pluto could contain 3/4 as much water as on Earth.
What is the big deal about water on other worlds?
Simply put, water equals life. On Earth, where there is water, there is life. All living organisms that we know of depend on water. With this logic, then the most likely places to find life beyond Earth would be those that have water, and specifically liquid water. Liquid water is a spectacular solvent, meaning it can dissolve substances. This property, combined with the fact that it acts as a medium, or place for substances to come together, allows for chemical reactions to take place. All living organisms are alive because of chemical reactions that occur at the cellular level, and without water, there would be no medium for those reactions to take place. So, we keep searching the vast frontiers of space, hoping that by following the water trail, we may discover life beyond that of our own pale blue dot of a world. Lake Storywater here. Are you interested in starting a podcast but don't know where to start? Well, I was in your boat too when I came to Anchor.fm. Anchor has many tools to help you start a podcast. They help record and edit your podcast, they distribute your podcast, and they provide some opportunities to make money as well. And the best part is it's free. So try it today. Download the free Anchor app or go to Anchor.fm to get started. Thanks for joining us on Story of Water. If you liked what you heard, why not subscribe to this podcast on your favorite podcast provider? Let your friends and family know about it as well. Connect with us and listen directly at www.story-of-water.com. Check out the blog or email us feedback. If you really enjoyed the show, become a Patreon supporter. Just click the donate button on our website. Remember, stay hydrated. See you next time on Story of Water.